Hello. So we today speaking about playing cyber chess. And imagine that you have lost your game and you would like to analyze what happened and to know, to see your wrong moves. But if you have only moves, you can only tell how the game went. But imagine if you had a full recording of what happened, like gestures of your opponent and face and things like that. And this is a bit about is my presentation, and it is a network traffic surveillance system. But to understand how it works, I will spend my first slide so you know exactly what we mean with those words, because they can mean many things. And our solution is basically standard network perimeter solution, which contains firewall, router, email security, and network traffic surveillance system, which is what I will be talking about today. And basically, to understand it, it works like video surveillance in normal life. It does not prevent anybody from stealing something, or like video doesn't prevent anyone from taking your goods. But it records. If somebody climbs your fence, you can then scroll it back and see that person. And if you're lucky and you have good cameras, you can see the face of the person and start to search for him. And this is pretty much the same. All traffic which goes through your network perimeter is recorded, stored in the disks, and indexed. So you can later analyze it for anything you may think you need it to be analyzed for. And by fully indexed, I mean down to the level of email attachments. Like if you have email with Word attachment, this Word attachment is indexed and is fully searchable later for any purpose you might need to be searchable. That means that if somebody is sending away something from your company and you want to know what exactly, like search for some keywords, you can do it easily. You just go into interface of NTSS, type in the search phrase, and you will get those, not only those emails, but you can also get those attachments that were actually sent, because they are reconstructed to application level. Like you can see on screen real emails which were sent. You can download those attachments. You can see if somebody downloads some videos, those files also are stored. And if somebody says, okay, I didn't download it, then you can show it. But see, there is a traffic, there is a file, you did it. This is about full text search. This is the screen from actual search. You just type in like in Google type search, and it has advanced search features which allows you to search by IP address, like other parameters. There is a quite long list of those. You can tweak your search in the way that you can get narrowed down results for just what you are looking for, and it is fast because it is not SQL, it's a non-SQL database by cluster point, which is somebody of you probably know. It's fast database engine, which basically, no matter the amount of data, how large they are, search is never longer than 5 seconds. Doesn't depend on size of database. It may be terabytes, it's scalable. You can scale it up and still have 5-second search or shorter. So most of the traffic, and I will touch it later because we have done some analysis, not most, but big part of traffic, let's say so, today is encrypted, SSL. And we have thought about it as well. And to monitor this traffic, we have developed thing we call SSL proxy, which is like how people call it, man in the middle, which just takes the SSL traffic, decrypts it, gives it to us, encrypts back, and sends the way to the user or to the server, depending on which way it goes. And it's completely invisible to the user, and it works. We have analyzed a lot of SSL traffic. I have examples. I will show it later. And to say that this solution is invisible to network and those who attack you anyway, because those other things, if hacker goes in, he may have suspicion that he's being monitored or things like that. This thing, like video camera, just records what happens and is basically invisible to anyone who wants to do something or just to the network itself. But why NTSS? Because it is not so obvious. Why should anyone need it to record all the traffic anyway? There are a number of uses I will be presenting. And first is unpredictable things, because we all know that from time to time something happens for what we are not quite ready. And when it happens, okay, it goes by, it does its damage, and that's it. But if you have this traffic recorded, you can then slowly analyze it and make your response much faster. So the next time the similar thing comes to you, you will be ready. And there is no better way to make such an analysis if only in the way if you have all the traffic. So you can just search it, analyze, and see what happened. Another thing, more for business use, is acceptable use policy. Many organizations and bigger companies, they have some rules on how their employees can use the internet. They have set up filters which don't allow to access certain websites and so on, but still sometimes it happens that those administrators are not able to follow everything new, and some new things just are accessible to guys who know them. And with NTSS you can easily see these things and react quickly. And there is an example about how it was unintentionally used during one presentation, but it will come later. And long-standing threats, we all know that sometimes it is so that something happens, but it happens slowly, like somebody is trying something once a day, twice a day to log in somewhere or to do something, and those analyzers usually don't trigger at those slow attacks, slow attempts to do something with your network. And of course, to use NTSS for that, you have to have suspicion that somebody is trying to do something. But at the second suspicion arises, you just need to go into the system and start looking. And eventually you will see that somebody is trying to, let's say, log into your system once a day, and it was going for 3 months. And then it's clear to you, okay, this is definitely a slow attempt to crack something, to get into your database or whatever. And next thing is you can set alarms to trigger in the cases like if you have some document in development, like in many institutions, it's true, and it's versions of it circulating around the email, but you don't allow those attachments to be sent outside your organization. You can easily set a trigger alarm which will detect that somebody is trying to send an email with a certain type, like let's say Word document, it doesn't matter, you can set anything you want, to the outside email address, and the moment this email is sent, the administrator of NTSS will receive email, okay, this person sent this email to that email address with that attachment, and you can, of course, because it's NTSS, go and see what exactly was sent and take actions. And last but not least, about why NTSS, because it collects all the network traffic. You can use it like a backup for your email, let's say, like a backup for your webmail. And if something goes wrong, you can always get all those data from this database because it's all there. Everything what was sent out and went in is still stored in this system. So it's a kind of possibility to use it. And there is an API which allows you to even use this storage, let's call it like a repository for something. You can even put in this database some data which are not gathered from network traffic. So it is a bit thought about those things as well. So if you decided to use for email backup, you can then develop a small tool which allows you to get those emails out in some kind of more readable forms that just go into search and search for a subject or something which was in the emails you need. And now about things we have actually done, or let's say NTSS have sometimes unintentionally done. And the first is about acceptable use policy. And it happened so that NTSS was demonstrated to one quite big company with ambitions, and they said that, okay, their acceptable use policy is rock solid, it's okay. It is, they have thought of everything. But the minute or so after the NTSS was connected to the network, it appeared that somebody is using CERT.LV, which is, you know what it is, and but it was forbidden for employees of that organization to use it. And they said it can't be, because we have all our bases covered, all the addresses are blocked. And it turned out that they have blocked name addresses, but not IP addresses. And clever people nowadays, you just type in IP address and use. And we were able to show them not only the fact that it was done, but the profile of the person who was doing with the picture of him. So it was quite educating for those guys. So it's a bit different story. Protection of personal data. We all know that it is not allowed to freely operate large amounts of personal identity codes, names, and things like that. But especially in state institutions, it sometimes happens that we just need those things for our work. And we use those in documents, and we prepare something and send it out, even not thinking that it contains something which is not being allowed to send. And again, it was in test mode. We set up NTSS, set up trigger, which was looking for personal identity numbers in Word attachments. And it turned out that from one organization, I cannot name any of those because they don't want, but still, it's real life case. Just were sending on a regular basis Word documents with personal IDs, and that is not very good thing to do. And about long-term slow threats, how we call it, it's again real life example. One of the company's employees was trying to access company's accounting system. But he was clever. He knew that if he will try to do it like frequently, something will trigger, some alarms will go off, and he eventually will be caught. And by knowing that, he tried to access just try and error principle once or twice a day, but for a long time. It was going on for like 3 or 4 months. And then somebody in company got suspicious that something with this guy is not as it seems. And they just went into the NTSS and made a search and saw that there is few hundred tries to access, but in a very long period, in like quarter or more. And it was instantly obvious that this is a real attempt to crack something. And now about some analysis. We set up, for test purposes, we set up Windows 10 and left it alone to do nothing. It will come in the end as a desert. But first, there are some other information from what we have done. And first is about, we all know that I already told it in the beginning that a big part of the traffic is SSL encrypted nowadays. In big part because of Google, YouTube, and Twitter. And maybe you have heard that Netflix in US is going to encrypt all its traffic. And because they are having 35% of all US traffic, most of US traffic, United States traffic, will be also SSL very soon this year. And knowing that, we make a survey of our customers who allowed us to do that in real life, what part of traffic they send in and out is SSL. And it turns out that in Latvia, 1/3 to 1/2 of real life traffic is encrypted already today. It's like, from small to quite large organization with a few hundred people. Don't ask me the names, I won't tell you anyway. Maybe you can torture me for them, but then after the presentation. One interesting thing we were able to make this graph. It's from firewall data. Those are attempts, just port scanners and things like that on the organization with a bit more than 200 outside IP addresses in 5-year period. So we just took numbers, made a graphic for anyone to behold. And as you can see, if you draw this long-term line, it's obvious that this trend is increasing. Number of guys trying to find the right port increases. So this is also quite interesting, at least for me. Another thing, you all know that when you type in search strings, browser shows you suggestions, like I was typing in Ugunssiena. This is from actual traffic, from actual SSL traffic. I just took those lines. Get from NTSS, and all this information, in this case, as we were playing with Windows, it's Bing search. It's just when you type character in search field, it just sends it to wherever it sends it, and is getting back those suggestions. And imagine if you type in your browser like XXX or something like that, it still is being sent to somebody who can then react to that attempt to search something. Like we all know that governments like to spy on their citizens, and if they ordered Microsoft to just give IP addresses of those who are seeking for something not allowed to their mind, they can just get this list. It's very easy. So, and another thing, if you want just to generate traffic by basically doing nothing, you can just sit and type characters into your search, because each of those characters generates about 1 kilobyte of traffic. But it's just if you have nothing to do. So, OneDrive. We set up Windows 10 without user and without configured OneDrive. But it still doesn't matter. It is not set up. It is even gray down there. It still communicates for reason unknown to whatever it communicates to one of IP addresses of Microsoft and tries to do something there. One of the things it actually tries to do is to check for update status of files, not for update status of OneDrive's updates, which would be normal, but even though it has nothing to synchronize because it's not assigned to account, it still tries to get updates. Do you have new files for me? And this is quite strange to us. But it's Windows 10 without user setup, so maybe other Windows versions don't do that, but in Windows 10 it does. So, and what we can take away from Windows 10 is it does send home a lot of data. We had no muscle to go through all those things they are sending. It's from 20 to 50 megabytes a day. It does send a lot of data, but what we can tell you for sure, they are not sending all your data. They are sending something they feel relevant to them. And this is the main takeaway from this Windows 10 setup. So, of course, it is very viable to its home, but it is not maybe as evil as some press makes it. And this is a graph from NTSS. Windows was left alone for 24 hours, and those are addresses it was connecting during that time. It was just sitting there and doing nothing. And all those addresses, of course, are Microsoft. I've whoised all of them, and all of those are Microsoft, except for one, which is Akamai, which is where Microsoft hosts its updates, so it's still a Microsoft. And all of traffic, 99.8%, is encrypted, so they are clever. They are sending those data, not in plain text. They SSL those data, so not anyone can read those. And that's it for my presentation. I believe you will have some questions. If not, you can ask them later.
Yes. Are there any questions? We have one.
Okay, please tell me how SSL pinning works together with NTSS. Thank you.
SSL?
SSL pinning.
Pinning?
Yes. It's embedding SSL certificate in your application, example iOS, and it does not work if certificate doesn't match with a certificate received from the server.
Probably there is some traffic which is not working. We know that. Probably it will not work. But if you want a specific answer, I can provide it for you later, because I'm not that technical. I won't be able to answer it right now. Sorry for that, but...
Okay, any other questions?
Are the PCAPs being encrypted, or they're stored just like simple PCAPs?
What?
The network traffic, you said it's being transferred to PCAP and then stored for searches.
Yes.
Are the PCAP data itself encrypted, or it's stored simple, without encryption?
No, it's stored as it is received in the drive of the system. If we receive encrypted traffic, we store both decrypted and encrypted version of it. If it's normal traffic, it's just written to the disk. If I answered your question.
Anybody else? Okay, if there are no questions unanswered, then we are a bit ahead of a schedule, but then again, it's coffee break time. But before we finish, thank you for your presentation.